Myles Perkins is an environmental engineer with Ecology. He works to reduce toxins in settings in which they are used. Myles is a supervisor of a group of staff who provide replacement assistance to businesses. Myles also manages Ecology's PCB and building materials project. As you're all probably aware, there's a lot of discussion around PCBs and building materials and source control in the stormwater world. Myles' talk will be pertinent to things that are in front of us. If you're permitting, I'm excited to see it myself. Everybody, Myles Perkins.
Yeah, thanks again, Trey. Really appreciate it. So I'm here to talk about finding and addressing sources of PCBs and building materials. And so again, I'm from the haz waste world. So I know this group's mostly focused on stormwater and other things like that. This was a huge effort, multi-program effort. We have a couple of folks that came to the room that were part of the project at one point. So if I get any good water quality questions, then we need to go to the audience. So let's jump in. So today I'm hoping to cover a couple of things. I want to talk a bit about the issue that I'm bringing up. I want to talk about what Ecology is doing to try to address and fill the gaps for that issue. I want to talk about the work we've done to date and how we've gone about establishing guidance and cost estimation tools, things like that. And then we'll talk about next steps briefly. So I'm going to try to blaze through these slides just so we cover everything and leave some time for questions. So the issue in 3 bullet points is back between 1950 and 1979, there was a lot of PCBs manufactured and put into building products. And so these building products have a wide range. I'll cover them in a second here. But there was also a huge boom in growth in the 1950s through the 1980s. So there's a lot of buildings out there that have this potential issue. Although this PCBs are regulated in building materials under TSCA, which is the Toxic Substance Control Act, which is a federal program, the source control is necessary to prevent impacts to water bodies. So what I mean by that is with regards to source control. These building materials, a lot of these PCBs on the exterior of the buildings, they leach off into stormwater, they create PCB issues, and those are regulated in the state. Additionally, one other piece of the issue is that there's currently little to no guidance that addresses exterior building materials. So EPA has a lot of guidance on indoor air quality. There's a lot of knowledge out there about what's in these materials. But when it comes to trying to be protective of leaching from these materials into stormwater, into water bodies, that's where we have this less guidance. So here's a couple pictures. I just want to point out some materials. You all may have a good handle of this. The interior stuff, we have light ballast. There's a lot of other building materials like ductwork, joint material, mastic. When you look at exterior, though, the piece that we're more focused on, you have asbestos roofing paneling. So that's a mixture of asbestos and PCBs. You have paints on exterior buildings. Paints, again, the way PCBs were incorporated were because they helped with durability. When contractors would be on site to paint sites, they would mix PCBs in on their own. So it's a high variety in which paints may have PCBs in them, which can be kind of confusing, but you do find it in paints quite a bit. Doors and window caulking, you can find pretty high concentrations of PCBs in those as well. And then joint materials in sidewalks, throughout building parts that aren't necessarily window caulking or door caulking. You can find PCBs in pretty high concentrations in all these things. There is a much longer list, but these are the kind of the main ones to focus on. Here's a quick visual on how PCBs migrate into stormwater. Precipitation will hit roofs, hit the side of buildings. They'll go into municipality stormwater. It'll go into stormwater as well. You additionally have construction sites here that if a construction site is not properly protected and you disturb PCBs and building materials, you're going to get much higher loading than you normally would. Additionally, indoor air quality, of course, is an issue and it can circulate, but it can seep into materials. And if you have deterioration of these materials and they get exposed to stormwater, you're going to have an issue. So these will eventually run off into surface water, sediment, and aquatic life, and contaminant aquatic life. I got a couple of regulatory slides. I'll try to get through these as best as I can and be as straightforward, but the regulations around PCBs can be a little confusing sometimes. So there's a couple of things here. When you look at PCBs and building materials, there's 2 types of waste you typically see. There's remediation waste and bulk product waste. Remediation waste is when waste is derived from a spill, a release, If a building falls down, if you have something leaks into soil, you then have a remediation waste that is regulated under TSCA. I'm sorry, MODCA, the Washington State MODCA. You also have PCBs in product waste, which is derived from manufacturing products. So this waste is actually regulated under TSCA. It's the waste that we're mostly focused on in the guidance. And ultimately, what this is before it's even a waste, these are standing buildings that are going to have materials in them. TSCA regulates when it's if materials are, if PCB concentrations are going to be greater than or equal to 50 ppm. So when a building is being demolished or renovated, you find PCBs in excess of these limits, you need to follow TSCA guidelines, and there's very, very specific requirements for that. One thing to kind of note, and this is very important, is that there is really currently no good mechanism for requiring owners to characterize before they are abated or renovated for these building materials. So TSCA says that if you find PCBs, the building and they're exceeding 50 ppm, you're no longer authorized to use the building. You must deal with the issue and again, cost and dealing with it. But right now, unlike asbestos, unlike lead, where there's really good testing requirements, PCBs does not have that in place. So typically other ways, it's more if you don't look for it, it's not an issue. But if you do find it, it's a big issue for you. This last one, again, if characterized and source identified, it could trigger further investigation. So keep that in mind. And this is part of some of the data gap that we're trying to address with this project. So in addition to waste regulations, just a couple of things under water quality. It's unlawful for any discharges to pollute state waters under RCW. Additionally, surface waters must be protected for their designated use, so recreation and aquatic life. So again, if you're going to have runoff, if they're going to be contaminated with PCBs, the state of Washington does regulate that. Additionally, NPDES permits, I've been calling them NIPDs for a while. I apologize, thanks to my consultant background. But NPDES permits, like municipal stormwater permits, do not authorize discharges that could cause a violation of water quality standards. So keep that in mind as well. I think PCBs are regulated on sale land. They aren't necessarily tracked up to a potential source, which are building materials. So, but these are other ways to get at regulation of PCBs. So with that said, I want to try to go through what we've been doing. So, we can do more. So currently PCBs being released in the environment via these external building materials is an issue. We expect that they're released in higher quantities during, demolition and renovation, especially if they're not being protected with stormwater BMPs. And additionally, these materials must be managed before they're disturbed or added to landfills. So what we want to do is we want to reduce leaching from these materials. If they're in a Subtitle D landfill, PCBs could be leaching. Additionally, we want to reduce the impact on human health from fishing. So for those that do subsistence fishing in surface waters, PCBs do accumulate in salmonoids, all types of fish, and are a big issue. So that's kind of what's driving us. So just to give you a quick summary of what we've been doing. So back in the end of 2020, Ecology was awarded $373,000 to set up a at the time it was called a PCB task force, PCBs and building materials task force. And so ultimately the group was set up to pursue pursue recommendations of the PCB chemical action plan. So that action plan has been around quite a while, but this was one of the first forays into addressing one of the issues. Also, we used this funding to establish this team, this PCBs and building materials task force, and we also are working with EPA to promote awareness of the issue. So work got started in early 2021, and we're just kind of wrapping up the project now. Goals were to address guidance for businesses and consultants to identify, characterize, and abate during demolition or renovation. So ideally, we know there's an issue when it comes to the potential regulation here. We want to make sure people that are going to encounter this issue have all the tools they need to deal with it when it comes up. So additionally, we wanted to make sure they could also properly cost and estimate the size of their project. That is a challenge in itself, and I get into it here in a second, but But ultimately, we wanted to make sure that they could understand what they're getting into if they look for PCBs. And then additionally, the end of this project was really set up to design the future of where this wants to go. So we're gonna, I'll talk a bit about a future abatement program that Ecology is gonna be hopefully promoting and pursuing in their future. So early work, we spent a year actually trying to research and compile data. There was quite a bit put together in a narrative review that we have available for folks. That narrative review really kind of sussed out the issue, looked at the research into building materials, into leaching studies, things like that. We set up a focus sheet that kind of introduced the topic. We talked a little bit about what we're going to be doing. Then we set up a web page where you can go see those images I showed earlier, and kind of get a handle on the project work. But the meat of the project was developing the guidance documentation. So we've been working on that this last year. I've already talked a bit about number 1. I'm going to get into 2, 3, and 4 here and talk about steps to identify and characterize PCBs, talk a little bit about the abatement and waste management of PCBs, and then also talk about stormwater BMPs that should be available to folks that are awaiting removal of the materials. So again, I'll try to go through these pretty quick. The guidance is actually published. You can go take a look at it right now, but I'm going to cover high level what it's aimed at. The first one, steps to characterize or steps to identify and characterize. We want to put something in the hands of contractors or business owners, give them something that they can use to kind of screen and inventory to find out what they have on site. Ideally, they would go through this document and be able to determine building age, look at the use and building structure, and then also look at other details such as going through the facility and finding suspect materials. We've tried to lay out as many of those suspect materials as possible in this document. Hopefully set them up to be able to quantify and look at dimensions of materials so they can get a size and scale of the issue. Please note again that you can't necessarily do this and do 100% accuracy on your own, but this is hopefully tools to kind of give you a ballpark of what you could be dealing with down the road. Additionally, we had in some information on sampling and characterization. So we put in information on how to develop a sample plan. We provided guidance on how to conduct representative testing. These tables were actually are consistent with the San Francisco Bay Area stormwater management plan that they have. They have a very similar process for their municipalities. And ideally, you're using these to kind of be able to best kind of characterize and find what's on site. Again, just want to point out it's greater than 50 ppm under TSCA, so you're going to have a bulk waste building material that is regulated by EPA. And if it's less than, other federal and state agencies, and there are some cases where states will regulate this, whether through water quality or hazardous waste. So, and again, if you're all used to asbestos and lead, these are very similar numbers to their work as well. And then the next part of the plan is to look at abatement and waste management. So ideally, we've put together the full spectrum of how to deal with some of the major components you see on site. So we talk about how to prepare a work plan. We look into waste handling, storage, and disposal. We talk a bit about the abatement process, so protecting stormwater during that process, making sure you're addressing exterior building materials. And I apologize, when I'm talking about abatement, I'm talking about demolition and renovation and the safe practice of addressing those issues. So apologies for kind of mixing up all the terms. And then, of course, we get into the specifics when it comes to these 4 main categories. How do you deal with caulking and expansion joints? How do you try to manage and deal with paint waste or coatings? Additionally, how do you deal with asbestos paneling on the sides of these buildings and other miscellaneous materials? I won't go through all of these, but I just wanted to also point out that we fully realize as part of the project that most businesses, hopefully folks will want to look for this stuff and be a part of it when they're going to be planning for demolition and renovation. But most businesses, at least in most buildings out there right now, are not necessarily wanting to take that step right away. So ideally, we set up a 4th section of this document that talks about BMPs you can put in place to try to be protective while you're awaiting, removal of them. So this is a full list. Training's part of it, coordinating with your municipality, planning for wet weather. We'll skip a couple. Here we go. Cover materials, protecting storm drains. And these are all specific to PCBs. So please take a look at that section. But ideally, these are being implemented before things happen on site, before you actually have a demolition or renovation to get rid of those PCBs. Okay, I'm doing it time. Oh, perfect. Okay. The last little thing I wanted to mention is that we also developed an estimation tool. So if you can go through and inventory your materials, we also have a tool that kind of goes through the full process that it takes in order to abate and get rid of your materials in a safe, legal way. And so I can link this tool for you all, but it goes through best management practices, talks about different plans you might need, talks about the demolition and renovation waste and waste disposal. Some of the issues we came into, like how to estimate projects, we assumed labor for current year, which was end of 2022. We talked about disposal costs, contractor markups. It is the full gambit, and we did run some tests with others outside of our agency to use the tool. Ballpark, it seemed to be working, at least for those first things. But we're hoping we get questions on this if people want to use it. But again, there's certain things we didn't consider, like building height, if it's a unique structure, a lot of safety concerns as well, if not needed. So and then next steps, we're going to be training on this, so I'll be doing a much more in-depth version of this presentation to a wider audience later in May and or June. And then additionally, we're going to be preparing that proposal. In that proposal, we have a range of outreach efforts, research requests when it comes to like maybe piloting one of these projects. And then additionally, potentially including some proposals for policy and potentially incentive funding for this type of work. So yeah, that's it. So yeah, thanks everybody.